All right, well, hope everybody's having a good day, but before we go ahead and get started, I do want to go ahead and kind of revisit some expectations that I have and a few responsibilities that you guys have as being part of the class, and specifically it has to do with the website and tutorials. Because I'm thinking, we're in the third week and I'm already having a lot of students miss for different reasons, but I don't think they're really understanding what to do when they're gone. Okay, so when you go to the website, and I hope at this point everybody has signed up. Okay, if not, I've got the codes. You can just ask me and I'll get those to you very easily. But any day that you miss, okay, you want to go to that current week. Remember, I record my lessons. Those are always dated. Like, for example, if you missed Monday, what day was that? That was the 27th, okay? So you look at the videos I've posted for that week. Here's Piecewise Functions Part 2. That means we started it last week. Okay, maybe we finished it, maybe not, maybe there'll be a Part 3. Okay, but in this case, we know we finished. But 82718. All right, now, the name of the video files is always the name as the notes that I post. So here we're talking about piecewise functions. So if you want the notes, just go to the week where we first started talking about those. We started talking about them last Friday. Piecewise functions, there you go. Okay, just like yesterday, we started talking about rational equations and inequalities. So the notes are here, part of this week. Okay, so here's what's expected and your responsibility. If you're absent for whatever reason, you have to go to this website and get your materials. Okay, you need to get the notes. Now, I do put extra copies over here on the door, but that's kind of rolling the dice because I don't make double copies for everybody. I make maybe 10 extra copies out of every set that I go ahead and print. So I've got 167 pre-calculus students, but I'm only going to go ahead and make 10 extra copies. So really it's first come, first serve. Your best bet is to go to the website, go ahead and get the materials that you need, kind of get caught up. Now, the tutorials are there for me to help you. Okay, now we'll talk about tutorials in just a second. Now, let's say there's a couple scenarios with the website. Let's say maybe you don't have a computer at home, or maybe you don't have internet access. Okay, we do have solutions to these. While the library has not yet gotten its computers, or at least I don't believe it's gotten its computers yet, there are computer labs on campus. Okay, maybe you have access to one, maybe you know one of the teachers, you can go in, print one out, okay? Maybe the problem is solved. Let's say you don't have access to one of those yet. Once the library gets their computers in, you could always go down there. Now, you're going to have to pay like 5 cents a page, but you'll have the notes. Okay, so let's say if that's not a solution. Okay, maybe you know somebody in class or somebody else from another class who I'm teaching pre-calculus. Maybe they would be nice enough to go ahead and print the notes for you. Or maybe you go ahead and just get the notes from them and you go ahead and copy down what you missed. Okay, this is really what I'm trying to emphasize. What's expected and your responsibility is you need to go ahead and get these notes while you're gone. Okay, does that make sense? Okay, so with the website, with the Remind, with everything I have, no matter how long you're out, you should always be able to at least keep up with exactly what it is we're doing. Okay, so if you have any questions about the website, let me know. Let's talk about tutorials for just a second. Now, guaranteed, 7:45 to 8:05 every morning, I'm going to be here to answer any questions you may have. Now, there may be a lot of people come in. I'm going to be doing my best to get to every single person, but that's time that I've set aside specifically for you guys. Now, the same cannot be said about after school. What's it say for after school? By appointment. I am really stoked that I've got people coming in after school. I don't want to turn anybody away, but if you don't talk to me, if you don't let me know that you're coming in, it's kind of like rolling the dice again on the papers here for the door. I may not have time to go ahead and sit down and talk with you. I may be leaving or have already left for the day. I may be going someplace for a meeting. The point is, you got to let me know ahead of time so that I will make time so that I can talk to you. Okay. Typically, if it's going to be in the same day, you got to let me know at least in the morning. Maybe or maybe not something can be done. The earlier you let me know, the better it's going to be. If you go ahead and come in passing period between 7th and 8th, less than an hour before school ends, which is what's happening a lot, I may not be able to accommodate you. Okay. And the tutorials in the afternoon, they're not infinite. They're going to be about 20, 25 minutes max, just like the morning tutorials, okay? So I just want to make sure that everybody's on board and everybody knows what's expected and what your responsibilities are. Does anybody have any questions? Okay, so we are good as far as the website and the tutorials. I'll take that silence as a yes. All right, awesome, awesome, awesome. Now, what is happening tomorrow? You've got your first exam. So anything from day 1 through today is fair game on the test. In fact, if you take a look at the website, I put a slightly more specific listing of what it is you'll want to go ahead and take a look at in order to be successful. But I will be here in the morning. Now, the only time I'm not going to be here in the morning is if there's some kind of circumstance out of my control. And probably if something like that happens, I'll send out a remind like, hey, this happened. I won't be able to make it for tutorials. Okay, but otherwise, I'm going to be here. Okay. Let's see. Is there anybody who knows for sure they're not going to be here tomorrow? Good, so we don't have to worry about that. So everybody, at least right now, is planning on being here tomorrow. We'll take our test. I don't know if your other teachers have told you yet. They sent out an email. What are we doing tomorrow morning? 9:15. We are practicing our first lockdown drill. So it's going to be in your 3rd period class, but you want to remember what to do in any class you happen to be in. If it were to happen in here, what would we do? There you go. We're going to go over here to this side of the classroom. Excuse me. Right by Savion and Stephanie, behind the tape, because we don't want to be visible to the door windows. I'm going to drop those blinds. I've already got 2 of them down to help with the reflection. And then we're just going to be quiet. Hopefully it's not going to last too long. They say it's not going to last too long, but we'll kind of just see, how that plays out. We just want to be prepared. All right, so that is happening. I think, unless anybody has any other questions, we're good to go. Dylan? Oh, were you just okay? He was just right. Okay. All right, let's get to it then. We were talking about rational equations and inequalities. All right, so something I want to go ahead and emphasize. How far did we get on that first problem? Every class was different. Does anybody still have that set of notes handy? No. I'm sorry, man. Okay, so we got to this one. This one right here? Yeah. Did we finish it? So we got the interval notation answer? I didn't think we did. I'll tell you what, I'll go ahead and just kind of recap everything. We'll go through the process just to make sure everybody's on board. Okay, so let's just kind of do a review just in case for those folks who weren't here. Okay, so let me go back over here. All right. Now, these are the first 5 questions that we were looking at yesterday at the top of the lesson, but the ones I really want to focus on are the inequalities. Where it's equal to 0, remember, those are your solutions, your roots. That's where the graph actually makes contact with the x-axis. But the function notation, that's interchangeable with y, because g of x, f of x, they just represent elements of the range, your y values. So where is it 0? That's the x-axis. Okay, y is equal to 0. Now, if you're greater than 0, you're going to be positive, right? And this is where your y-axis is going to come into play. When I'm asking you specifically, where is g of x greater than 0, where is y greater than 0, I'm asking you where it's positive. So anywhere above the x-axis, you're looking at positive range elements. So where would you be negative? Down below, right? Anything less than 0 would be negative. Anything above would be positive. So the x-axis represents 0. So that's what we're looking for. Specifically, what parts of the graph are above, what parts of the graph are below. We refer to those as pluses and minuses. Okay, so let me run through this example. kind of catch up to where you guys were. So the first thing, we went ahead and factored it. X plus 1, X plus 3, all divided by X minus 1, X plus 3. Okay. And then, of course, less than or equal to 0. Okay. Now, we already created the sign chart. We got values that were put on the sign chart. Where did we get those values from? There you go. The factored version makes this very easy to do. I'm going to take every group factor that I see, and I'm going to set it equal to 0. Okay? So X plus 1. X plus 1 is equal to 0. This tells me X equals negative 1. X plus 3 is equal to 0. This tells me X equals negative 3. What's the only group left? X what? Minus 1. So if X minus 1 is equal to 0, then this tells me X is equal to 1. These values are very important to me. These are values that make both the numerator and the denominator 0. So that's what's going to go on my number line. Okay? Now, specifically, we're going to refer to those as exactly what they do to the function. Any value that comes out of the numerator, we're going to call him a 0. Because that's what he does. 0 divided by anything is going to give you 0. If it comes out of the denominator, we're going to call it undefined. That means that value is forcing you to divide by 0. We can't do that. Okay, so let's put these on my sign chart. Now remember, this sign chart, that represents the x-axis. All right, so I have negative 3, negative 1, and we have a positive 1. Now, anybody who comes in and takes a look at our work, we want them to be able to understand what it is we're trying to say. So we're going to label these values. Which value or values came out of the numerator? Okay, now, one of those we'll kind of talk about, but definitely negative 1 came out of the numerator, right? Because he came out of the numerator, he's a 0. So I'm going to label him as 0. Now, the negative 3 is a special case. He actually comes out of both the numerator and the denominator. Okay? We have a common group factor. What's he going to cause to be in the graph? Remember, what have we talked about? It starts with an H. He causes a hole. If there's a common group factor above and below, it creates a hole. Now, this is one of those interesting little things that just happens. If you have a common group factor above and below, the value that comes out of it, we're going to call it an undefined. We're going to say it's coming from the denominator. Okay? Because while, yes, it is going to make the numerator 0, the more important idea, it makes the denominator 0, and that's the bigger problem. Okay? So if it is on both the numerator and denominator, we're going to focus on the denominator. Where does the 1 come from? He comes from the denominator as well. Okay. Now, we've already looked at the graph. We already know what this guy looks like, right? But here's what should be happening when somebody walks in. They take a look at your work. They say, okay, these negative 3, negative 1, and 1, they have to be important values to the graph. So I know because there's a 0 above negative 1, guaranteed I know that has to be my x-intercept. The graph has to cross here. At negative 3 and 1, the undefined tells me there's some kind of discontinuity. More likely, they're going to be vertical asymptotes. In this case, we also know one of them is a hole. Okay, so we should already be able to tell some information just by looking at it. Will I have inclusion? Any closed circles? Okay, Aiden, you were just saying 1, but we have 3 values. Which one will I include? She says negative 1. So definitely we'll include the negative 1. But wait a minute, why am I not going to include negative 3 and 1? It says equal to. They're undefined. And this is what it's very easy to forget. Even if your inequality says to include it, no matter what, the undefined values will always have an open circle. Okay? Because what do they do to the function again? They force you to divide by 0, and we can never do that. So even if it says yes, include them, we know we can't. Okay. Now we're almost done. This is actually half of the work already. Okay. Well, actually more than half when you really think about it. I've created 4 intervals because I've got 3 values here. I just want to know each of those intervals, whether they're positive or negative, hence why we call them sign charts. We're only interested in the sign. So let's start here. I need a number between -1 and 1. 0, perfect. As long as it's between those values, you can use whatever you want. I could even get really close. I could say 0.9 and it would still work. You just can't use those endpoints themselves. Okay. So did we talk about this yesterday? What do I do with that value? Or did we get that far? We plug it in. Now you can always plug it back into the original. I prefer to go ahead and plug it into the factored version. I just think it's faster. So for example, we chose 0. So I'm going to plug it into this first group. What's 0 plus 1? 1, but that's a positive number. Now, if you want to put the number, you're more than welcome to, but again, I'm only interested in sign. What about 0 plus 3? That's a positive 3, okay. Over 0 minus 1, that's a negative, and then 0 plus 3 will give me another positive. You notice I'm putting a plus or a minus to mimic the groups that I have right here. So what's a positive divided by a negative? Negative. I know that whole interval has to be negative. Okay, and I want to do this for each of the intervals that I created. Okay, Savion, I need another value, something between -3 and -1. -2, perfect. So this interval I chose -2, I'm going to do the same thing. Okay, what's a -2 plus 1? -1, so that's a negative. -2 plus 3? That's a positive 1, okay. Over -2 minus 1? Negative, and again, -2 plus 3, we already know that's a positive. So negative divided by a negative, I know this is a positive interval. There you go. Is everybody seeing how I'm doing this? Is anybody confused? Any questions? Okay. Zach, I need something less than -3. -4, perfect. I'm going to take that value I choose, and let's plug it in again. -4 plus 1. That's definitely a negative, -3. -4 plus 3. It's another negative. So the 2 groups up top each gave me a negative. First group in the denominator, -4 minus 1. Negative. -4 plus 3. Negative. So what does this guy become? Positive. Okay. Last one. Okay. Miriam, I need something bigger than 1. 4. Perfect. Okay. And on an interval like that where you have no boundary, I mean, could you choose like 1,000,000? You could, and I've seen students do it. I would choose numbers that are super simple and quick to work with. It's still going to work. Okay. But let's choose the 4. 4 plus 1. 5. Positive. 4 plus 3. Positive. 4 minus 1. 4 plus 3. Positive. So that is definitely a positive interval. Okay. Now the work on your sign chart is done. All you have to do is write your answer. But how do we know what my answer is? Okay. Well, I'm glad you asked. Your inequality, whether it's less than or equal to, it does not matter if you have equality. If it's less than 0, you want every interval you found to be negative. Okay. If your inequality says greater than or equal to 0, you want every positive interval that you came across. Okay. So what does our inequality say? What's it want? Less than or greater than? It says less than, so I want any interval that's what? Negative. Okay. Well, how many negative intervals did we end up with? Yeah, just the one. Only right here. Now, once you identify the interval or the intervals, you write that in interval notation, and you are done. This solves your inequality. Any value of x in this interval is going to make it true. No other value is going to satisfy the equation. So we see it's between -1 and 1. How am I going to cap this? bracket because the negative 1 is included, and parentheses because the other one's not. That's my answer. Okay. Now, the reason yesterday why I took so much time to look specifically at the graph, are you ready to have your minds blown? Okay. You're shaking your head no for, okay. But -3, -1, 1, okay. Let's remember the pattern. Right below this, you have the graph again. Here's -3, here's -1, and here's 1. Would everybody agree? Now, look at your pattern. Okay, it goes plus, plus, minus, plus. Okay, so plus, plus, minus, plus. What is that telling me? You'll notice, what's the graph doing in the regions we got a positive? It's above the x-axis. Everything from -3 lower, he's above the x-axis. Between -3 and 1, he's still above the axis. From 1 and greater, he's still positive. He's above the x-axis. What was the only interval we got negative, and the only interval where he's below the x-axis? -1 and 1. Okay. See, that's why sign charts are so useful to us, because even without the graph, do we have a really good idea of what's happening? Okay. Now, we don't see 100% the entire picture, but we know enough that we could reasonably make certain statements. Okay. How are we doing? Is this make it a little better since yesterday? Okay. All right, well, let's try another one. Let's see what you think. Let's try another one, because I know you guys want to get to it. Okay, now we got this one. Again, these are your steps. If you want to refer back to it, if you forget what we talk about, you've got those right there. Okay. And also this one, what's already been done for you? It has already been factored. Okay, now I am going to go ahead and write it like this. I'm going to say x plus 3, x minus 1 over, I'm going to say x plus 2, x plus 2. Okay. Now, it's already compared to 0. I'll talk about that in just a bit. But before we do anything, can anybody already tell me, when I finish my sign chart, will I want all the positive intervals or the negative intervals? Why negative? Yeah, it says less than 0. So see, I already know what it is that I'm looking for before I get started. Okay. So I'm going to go ahead and draw my line, this sign chart. Now remember, this is the x-axis. Okay. So how do I find the values that go on there? Okay. Satish. There you go. Set each of those group factors equal to 0. So x plus 3 equal to 0. Then I get, I want to put equals. I get x equals -3. X minus 1 is equal to 0, implies x equals 1. And we have a double group down below, so I'll just do it twice. X plus 2 is equal to 0, so x equals -2. All your group factors you set equal to 0. You find the values that make the numerator 0 and the denominator 0. Looks like this time I got -2, -3, and 1. So I'm going to put those in order. -3, -2, and 1. Okay. Now let's practice this. I'm going to give you 30 seconds. Label what you believe those are. A 0 for a 0, a no solution symbol for undefined, and decide if you're going to put closed circles or open circles on the values themselves. Okay, so take 30 seconds and try that. Let's see if we can all match up. And remember, even if you're not sure, try. Okay, write something down, make your best guess. I know it sounds like kind of a cliche, but have you ever heard that saying, you miss 100% of the shots that you don't take. Has anybody ever heard that before? Okay. So if you don't try, I mean, you're guaranteed not to get it. I mean, at least give it a shot. Okay, now one question before I go ahead and write down what we're supposed to have. Would this guy have a hole? Okay, Miriam, you're already saying no. Would you guys agree? Susie shaking yes. Okay, people are shaking yes. But wait a minute. I see a double group. I thought it was a group that repeated, right, Savion?
But it's not.
It's not in the numerator. You have to have the same group in the numerator and the denominator so that they cancel. Okay, if no group cancels, there's no hole. This guy would not have a removable discontinuity. Okay, good. Well, let's see. What value or values came out of the numerator? The -3 and the 1. So I'm going to put a 0 above those. They came out of the numerator, so they're zeros. Guaranteed, what's going to happen there? What's the graph doing? It's crossing at those locations. Now, whether it's curving down, curving up, we don't know. But we know it crosses there. Where did the -2 come from? He came from the denominator, so he's my undefined value. Okay. Now, no matter what happens, we never include the undefined value. Always an open circle. But what about the other two? They are included? What's my inequality say? Less than. We don't have equality. So both of these would be open circles as well. The only time I can put closed is if we have the equality. Okay. So how are we doing on that? Any questions? Now all we got to do is figure out my signs. Okay. Ethan, where would you like to start? What interval? Okay. What would you choose? Okay, he chooses 0 between -2 and 1. So the value we choose, I'm going to plug it into the factored version. Remember, you can always go back to the original problem if you want to. Okay. So let's see. 0 plus 3? 3, so that's a positive. 0 minus 1, that's a negative. Now, it always repeats, so we only have to do it once. What's 0 plus 2? A positive, so I'm going to put a positive. Okay. We want to put it twice because I have 2 groups, but we only have to evaluate it once. Is everybody okay with that? So what would this one become? This is a negative. So is this already going to be something I want to write down as an answer? Yes, it's a negative interval. Well, let's see what else. Susie, where would you like to go next? To the left. So far left? Okay, what's less than -3? -4. Perfect. Okay. So -4 plus 3. Negative. -4 minus 1. Negative. -4 plus 2. Negative. So that's a negative. So what would this be? This is a positive. So it's going to be a positive divided by a positive. So positive. Is that part of my answer? No. Okay, he is positive. I want less than 0, the negatives. Okay. Where to now? Okay, now what can I put between -3 and -2? Yeah, -2.5. Even if it's a decimal, as long as it works. Okay, so let's do the same thing. -2.5 plus 3. That's definitely a positive. -2.5 minus 1. Negative. -2.5 plus 2. Negative. -2.5 plus 2. Again, another negative. What would this one be? That one becomes negative. Now you also notice, are we moving through this one a little faster? Because we already know what it is we're looking for. We know the steps. Okay? And if you ever forget, you got these steps right here, part of your notes. Okay? Last one. Greater than 1. Ford, what do you think? 10. Okay, perfect. All right. So let's see. 10 plus 3. 13, so positive. 10 minus 1, positive. 10 plus 2, so that's a positive. So this is definitely a positive. Okay. All right. Now, we wanted the negative, so any interval that's negative, I want this one, and I want this one. Okay, so here's my question. Can I just go ahead and say it's everything from -3 to 1? What's the problem? Okay, that -2. So for this one, I'm going to take the union. I'm going to say -3 to -2, union, -2 to 1. This is my answer. Now again, you've got a graph of this one. Compare what we just found. We have the values of -3, -2, and 1. Okay, so I'm looking at this graph. And let me do this in red. It'd probably be a little easier to distinguish from this. So here's the -3. Here's the -2, which was a vertical asymptote. And here's the 1 that did turn out to be my root. It's crossing right there. Okay, well, what was the pattern? Remember, it was plus, minus, minus, plus? Okay. So here it was plus, minus, minus, plus. Okay. And is that graph showing me exactly what we got on the sign chart? Everywhere we got a positive, the graph is where? It's above the x-axis. Everywhere we got a negative interval, it's below. Okay. All right. How are we doing? Yes, sir. Oh, how come I put a union? Because we had more than one interval. So my answer can come out of either of these, this one or this one, so I want to take the union. So if you have just more than one interval, you want to do this. Now, just like with domain and range, it's always a good idea, once you've written your answer, to see if you can do what? What do we always like to do in math? Simplify. We like to simplify. Now, unfortunately, this one can't be simplified. We have to leave them as it is. But sometimes it can be. Okay. All right. Are you ready for one on your own? Yay. Okay. So let's take a look. Let me go ahead and take this off. Okay. So we've got our first one here. Now, it's my rational function, but it says greater than or equal to 0. So, Bethany, what am I going to be interested in? Positive or negative intervals? I want the positive intervals. So we already know what it is I'm going for. Okay, but this one's slightly different with just one little thing. It's not a huge issue. But does anybody notice the denominator? What about him? Stephanie, you're already shaking your head yes. There you go. So here's what I'm going for. Can he be factored? Are there two numbers that'll multiply to give me 2, but that will add to give me 4? No. Now, just because he can't be factored doesn't mean that we're still not going to have values. So this is where you're going to have to use something else. Now, if it's factorable, fantastic. But do you remember quadratic formula? Even if you remember completing the square, you still got to find values of x that will make the denominator 0. Now, it's probably been a while, so before I go ahead and turn it over to you guys, I'm going to help you out. Okay, what is the quadratic formula? Okay, there we go. And you can always tell the students who had a teacher who taught it to them as like a song. Opposite of b plus or minus square root b squared. How many of your teachers did it? A few did. And how many just said memorize it? Okay, so we have my A, B, and C. Let's go ahead and plug in. I'll help you simplify, and then I'll let you take it from there. Okay, so let's see. The opposite of B. -4 plus or minus the square root of B squared. 16 minus 4 times A times C, all divided by 2. 2 times A, 2 times 1. See, all I'm doing is just plugging into the formula. Okay? That's why the quadratic formula, if it's not factorable, is typically the top one students go to. It's very, very easy and straightforward. Does anybody in here like completing the square? For some folks, so that's still a great method. Okay, so let's see. I'm going to have x equals -4 plus or minus the square root of 16 minus 8 will give me 8 over 2. So what would the square root of 8 be if I were to simplify it? 2 square roots of 2. Very good. And all this is over 2. So you'll notice this can still be simplified because both numerators have a common factor with the denominator. So I'm going to say this is negative 2 plus or minus the square root of 2. Now that's great if you're solving it by hand, that's what you're going for. But when creating a sign chart, negative 2 plus the square root of 2 really doesn't help you out a whole lot. Okay, so I've already got these taken care of. I'll go ahead and let you know one of these becomes negative 3.4 when you approximate it. The other one becomes a negative 0.6. And if you have a calculator, you can confirm that. Okay, so this is where I'm going to go ahead and turn you loose. Here's my sign chart. But how many values will go on the sign chart? Is it just those two? Where's the third? Don't forget the numerator. Okay, so I've helped you take care of the denominator. So find what value makes the numerator 0, then you can set up your sign chart. Okay, so while you guys are doing that, I will pass back your papers. Okay, 4. Ariana. Let's see. Dylan here. Raphael. Let's see. Erica. Erica, that's right. Okay. Go. Kimberly. Welcome. Aiden. Satish. Ethan. Alex. Susie. Skylar. Rhett. Verunda. Fawaz. Okay. Jack Williams. Because Jack Osborne's not here. Saul. Okay. Bethany. Okay. Could you pass that to Savion, please? Okay. Xavier. Let's see. Jacob. Jacob. Was he here? Jacob. Okay, Jacob right there. Okay. Sorry about that, sir. Then we have Jasmine. Okay. Christian. All right. Matthew. All right. Okay. Zachary. Kyle. Okay. Miriam. Ford. Stephanie. Wah. Jane. Shayna. Okay. Got Jack. I got another Jacob. There you go, Jacob. I got Dylan. Okay, Juan is not here. He checked out. And Connor. Okay, that's all we got. Perfect. And we get out of here at 52. Okay, so we still got time. Good, good, good. All right. So, what's that third value that's going on the sign chart? Okay. So again, set that equal to 0. We know x equals 3. So I've got 3, negative 3.4, negative 0.6. So I'm going to put those in order. Negative 3.4, negative 0.6, and 3. So this is the only unusual one today. Even if you come across a numerator or denominator that can't be factored, you still want to find those zeros. Okay. So let's see. Negative 3.4, negative 0.6 both came out of the denominator. 3 came out of the numerator, so he's a 0. Let's see. We do have equality, but I can only include a 0. Remember, I can never include the undefined values. Okay. Would you guys like to tell me, or would you like to run through the process? You want to tell me the signs, or we go through it? Run through it. Where do we start? Well, let's just start at the far left. I need something smaller than negative 3.4. Negative 4, perfect. Okay, now the only change is that because this guy, he's not factorable, that means I'm actually going to plug in for every x that we have. So up top, negative 4 minus 3 is still a negative number, right? Well, let's say negative 4 squared would be a positive 16, plus 4 times negative 4 plus 2. So would that end up giving me a positive or a negative? That's a positive, so this whole interval is negative. Okay. Now I need something between negative 3.4 and negative 0.6. Okay. Negative what? Negative 1, that'll work. Perfect. All right. So negative 1 minus 3, that is a negative. Over. Let's see, negative 1 squared is 1, plus 4 times negative 1, and then plus 2. So that'll end up being negative. So a negative over a negative, that's a positive. How are we doing so far? Okay. Negative 0.6 and 3. 1. Okay, let's do the same thing. So 1 minus 3 would give me a negative number. Over, okay, so 1 squared is 1, plus 4 times 1, plus 2. So that's definitely a positive. So what's this guy? He's a negative. And one more, bigger than 3. 4. Okay, 10. They will all work as long as it's on that interval. So let's see here. 4 minus 3 is our first positive numerator that we've gotten. 4 squared would be 16, plus 4 times 4, 16, plus 2, positive denominator, so that's a positive overall interval. Now, what were we looking for again? I can't remember. We wanted the positive. So I want this one, and I want this one. So to answer that question we had again a little while back, will this be one I have to write union? Yes, because I have 2 intervals. So let's see. How would you write that? Negative 3.4, comma, negative 0.6. Parentheses on both. 3 to infinity. There you go. Bracket on the left. Okay. Now again, think about the answer that we just got. This is the one you don't have a graph of, so let me go ahead and quickly plug him in. X minus 3, so I'm going to come on over here. Control divide, X minus 3. Dip, 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 dip. Dip, 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 dip. Okay. Control divide. There we go. So X minus 3 over, it was X squared plus 4X plus 2. Okay. So let's look at our graph. Now, we got a value of a negative 3.4. So negative 1, negative 2, negative 3. So 0.4 would probably be right about here. I know he's a vertical asymptote because there wasn't a common group that he canceled with. He's not a whole. The other one was at negative 0.6. Okay, so there's the negative 3.4, negative 0.6. What was the 0? 3. So this is where it was crossing. And does everything match up? Everything is exactly as it should be. All right. So if you have any last minute questions, guys, I'm here in the morning. Otherwise, we got our test. Thank you very much. Have a great day.